Page 14. Section 1-2 is called linear measure, and we have two learning targets here. We're going to define line segment, and we're going to construct a copy of a line segment. Now, we're going to learn some other things too, but those are our two learning targets. So we need to know the definition of a line segment, and we need to learn how to do a construction to make a copy of a line segment. All right. Here's the definition. A line segment is a measurable part of a line consisting of two endpoints and all of the points between them. I'd rather you know that definition than the one in the book. Okay, so you need to write this one down. A line segment is a measurable part of a line consisting of two endpoints and all of the points between them. And that will be a quiz question in some way. Be multiple choice, matching, fill in the blank, or you write the definition yourself. And if I ask you to write it yourself, it doesn't have to be necessarily word for word, but it does have to have the same meaning. Okay? So a line segment is a measurable part of a line consisting of two endpoints and all of the points between them. Now, a line you can't measure because it doesn't have any end points. There's no place to start measuring. There's no place to end measuring. But a line segment can be measured because it has two end points. You use one of the end points as your start, the other one as the end. Okay? Now, a segment with endpoints A and B can be named segment AB or segment BA. So like with our lines yesterday, it doesn't matter. The order you put the letters doesn't matter. The measure of segment AB is written as AB, like we talked about again yesterday. The notation is don't put any symbol above it, and it means length of or measure of. Okay? And again, you could put BA instead of AB. That would be all right. The length of a measure of a segment always includes a unit of measure, such as meter, inch, kilometers, whatever. Okay? Now, you also need to realize that none of our measurements are going to be exact. They're all going to be approximations, and they all depend upon the smallest unit of measure available on your measuring instrument. For instance, if you had a ruler that was 12 inches long, it's a foot, but no inches were marked off, well, the best estimation you can do is to the nearest foot, isn't it? Okay? So if you had inches marked off, but none of the others, well, then the best estimate you could do would be to the nearest inch, and so forth. So don't be overly precise. Don't be more precise than you actually can be. Don't guess, is what I'm trying to say. Okay? Go by the smallest unit of measure that's on your ruler, meter, stick, whatever it is. Now, we need to talk about betweenness. Okay? For a point to be between two other points, it has to be on the same line as the other point. All right? So in geometry, between is a very precise thing. Like, just here, we might say something like, Hazel is between Murray and Paris. All right? And we all know what we mean. But if I get a map out, if all three of those towns are not collinear, then mathematically that was an incorrect statement. Just talking in general, it's a perfectly valid statement, right? Hazel is between Murray and Paris. But in math, in geometry at least, for that to be true, there'd have to be a straight line from Murray to Paris, and Hazel would have to be on it. Okay? So, look at this figure up here. There's A and B. N is between A and B because N is collinear with A and B. B is between N and R because B is collinear with N and R. N and B are both between A and R. And look at point P up there. P is not between A and R because it's not collinear with A and R. See the difference? See the preciseness you have to work with? Okay. Now, betweenness of points, this little box here. Point M is between points P and Q. And look at it. With the definition I just gave you, that it has to be collinear with it, it makes sense, right? M really is between P and Q because they're all collinear. But here's the formal fancy math definition, right? Point M is between points P and Q if and only if P, Q, and M are collinear, so, right, collinear, and that means the length of PM plus the length of MQ equals the length of PQ. And think about it. It's got to work that way, doesn't it? So if M really is between P and Q, if the length of PM were, let's say, 4, whatever the unit is, and the length of MQ was 2, if M really is between P and Q, they really are all collinear, doesn't that mean the length of PQ has to be 6? All right? And it works both ways. If we know that M is on the same line as P and Q, we know that we can add the 4 and the 2 to get the 6. If we didn't know, if we weren't sure, if I made the drawing, right? And so it's not a book drawing, so you really kind of can't tell. In fact, so I make a bad drawing, and I put P here, and Q here, and M here. But then I tell you that the length of PM is 4, and the length of MQ is 2, and the length of PQ is 6, then that means that even though the drawing's not very good, that means M is between P and Q. It's got to be collinear that way, doesn't it? So you go by your information. Now the book's drawings look correct. My drawings, sometimes yeah, sometimes no. Your drawings, sometimes yeah, sometimes no. So you go with the given information. If you're told these things are true, then they're true, even if you can't draw it very well. Okay? So if you know that M is between P and Q, you know that PM plus MQ equals PQ. Or if you know that the numbers add up such that PM plus MQ equals PQ, that means M's between them. And that's what the if and only if means, that it works both ways. Okay? You still with me? Wow, we just took something simple that you've known for years and made it complicated, didn't we? That's what mathematicians do. Okay? Because they got to be precise. They're not making it complicated on purpose, but it's got to be precise. We would have big trouble later on down the year if between didn't mean this. Okay? So they've got to be precise. When I say things like they make it complicated, I'm not insulting them. I'm actually in awe that they were able to think this all the way through so that it all fits together. All right, let's take a look at a few problems from your assignment. So flip on over to page 18. And the directions say, and do write these down, find the measurement of each segment. Assume that each figure is not drawn to scale. So in this book, and in fact in any book I'm familiar with, the figures are not to scale. Okay? So when that says 1.1 inches, it's probably not really 1.1 inches. If it is, it's just coincidence. Okay? But unlike if I draw it and I try to convince you that that's a line segment, when the book draws it, if it looks like a line or it looks like a line segment, it is. Okay? So number 5 there. That looks like a line segment. It sure looks like E is on the same line as CD, as C and D, right? So it is. We are able to know that. So since E is on the same line as C and D, that means E is between C and D. So to get the length of CD, can't we just add 1.1 and 2.7? Yes, we can. Eventually, we will call that the segment addition postulate. Right now, we're calling it common sense. Okay? And what is 1.1 plus 2.7? So, the length of CD, use the proper notation for the length of CD, equals 3.8 inches. Don't put the line above it, because if I did that, then I'm saying the segment. I don't want the segment is the actual drawing. The length of it is the number. Okay? Everybody get that? The segment itself is the physical drawing. The length of it is the number. So that's why we don't want the symbol above it. All right, number 6. S is between R and T. They're collinear. So they want us to find the length of segment RS. So the length of segment RS, well, I don't want to add this time. What do I need to do? Hey, I got to subtract it this time. And again, this is still using what we're eventually going to call the segment addition postulate. But do it. What is 4 minus 1.6? So 2.4 centimeters for the length of RS. So far, so good. Kind of piece of cake, right? Number 7. Let's throw a little algebra in here now. Find the value of x if the and the length of BC. So we got to find two things. Y'all need to read the directions. Okay? Most of the time we don't like to read the directions. Read the directions. We got two things to find. X and the length of BC. If B is between C and D. Now I told you yesterday, a lot of times you don't need to draw the figure. I want you to draw the figure on this one. I'm going to draw B is between C and D. So I'm going to make a segment. I'm going to put C on one end, D on the other, and then B is between them. Now it doesn't say halfway between them, it just says between them. So B. Now again, our drawings don't have to be to scale. So once they give me information, if it turns out that BD is supposed to be longer than CB, so what? So my drawing's not to scale, okay? But this is going to help me set up any equation I need. Now let's label the information that they give us. The length of CB equals 2x, so I'll label that. The length of BD equals 4x, so I'll label that. And the length of BD equals 12. Look, I'm going to label that same segment as 12. So our first task is to find the value of x. Well, look at your drawing. And what equation can I set up to find x? Well, right, I'm going to end up dividing 12 by 4, but the equation is 4x equals 12. The 2x I don't need for the equation, do I? So, 4x equals 12, and then 12 divided by 4 is 3, so x equals 3. They haven't given us any units, so I don't know what that unit would be, but x equals 3. So, I've done the first part. Now I'm supposed to find the length of BC. So, I'm going to circle that. You don't have to circle your answers. I usually don't, but I will now. That's my first answer. Second answer, I need the length of BC. Now, they told us that CB equals 2x. Well, CB and BC are the same thing, aren't they? Because the order you put the letters in doesn't matter. So that means BC equals 2x. And yes, that's the way I make my x's. Okay? Since x equals 3, substitute x, or substitute 3 for x. And then BC equals 6. Make sense? Yeah, I thought it would. Let's try number 8. So, let's draw it again. So remember, in the directions, they told us that B is between C and D. So I'm going to draw the same kind of drawing. C, D, B. And I'm going to label the information they give me. The length of CB equals 4x minus 9. The length of BD equals 3x plus 5. And the length of CD equals 17. Now, CD is that whole entire segment. So labeling that, I'm going to drop it down a little bit so it doesn't look like it's the length of either CB or BD. And here's how I indicate that it's the length of the whole segment. All right, you put those little markers showing the beginning and the end of the length of 17. And in a minute, I'll think of what those markers are called, but right now, my mind's a blank. I don't remember what we call those. All right? We got to find X first. Any ideas? Yep. We want to add the length of CB plus the length of BD, and it equals the length of CD, doesn't it? And then you go from there. That'd be 7x minus 4 equals 17. 7x 21. X equals 3. Figure out the length of BC. Anybody get the same thing I did? Now that I know the length of BC is 3, my drawing was way out of scale, wasn't it? Did that affect the way I worked the problem? Did that hurt me in any way? No, not at all. Any questions? All right. Segments that have the same measure are called congruent segments. Now, I've learned over the years that in many countries, they just always use equal, and I kind of wish we did. Well, I don't even know that it's true now. I know that in the past, in Great Britain, they would have said segments that have the same measure are called equal. In the United States, we make a distinction. We say that numbers are equal, and figures that are the same size are congruent. Okay? But it means equal. It means they're the same. So if two segments have the same measure, the same length, we call them congruent segments. And the way you mark congruent segments is with a little hash mark, like you see here in the drawing, where it says congruent segments have the same measure, and AB is congruent to CD because they have the same measure, 1.7 centimeters. And then see the book always uses red or pink, whatever that color is. Well, obviously we won't. So if I had two congruent segments marked here, and I've really got to do a better job with my pen. If I had two congruent segments marked here to show that they're congruent, I would just do that. Okay? Then if I had a different pair of congruent segments, I'd use two hash marks to show that those two were congruent. Okay? Now, this little symbol here, an equals with a tilde above it, that's our congruent sign. And you use it just like, you say it just like equals. Instead of saying such and such equals such and such, you say such and such is congruent to such and such. Okay? So this symbol right here, this notation means segment AB is congruent to segment CD. Now, if this is true, if segment AB is congruent to segment CD, that means, by the definition, or this definition, whichever one, that means that the length of AB equals the length of CD. Now, if you know one, you know the other, don't you? If I tell you these two segments are congruent, you should conclude their lengths are equal. If I tell you the lengths are equal, you should conclude the segments are congruent. Still with me? Let's take a look at number 9. It says, the Indiana state flag was adopted in 1917. The measures of the segments between the stars and the flames are shown on the diagram in inches. List all of the congruent segments in the figure. Okay, so let's take a look here. Look up here, and we'll do this together. I see two different segments that are 10.8 inches. There and there. So they're congruent to each other, aren't they? So that's my first thing. So segment AG, use the segment symbol, is congruent to, make your congruent, segment GF. All right, then I see another pair of congruent segments. I see that the length of BG is 8.4 and the length of GE is 8.4. So that's my second set of congruent segments. Segment BG is congruent to segment GE. And by the way, if I call it BG and you call it GB, is that okay? Yep, that's okay. And you know it, what's the last one? And there we go. Use the proper notation. Use the segment symbols. Use the congruent mark, or the congruent sign. All right. So let's see, what was our first learning target, by the way? Define a line segment. Did we do that? Yeah, we did that. Okay. Our second learning target was to construct a copy of a line segment. We haven't done that. All right, let's see, what page is that on? That's at the bottom of page 17. Now, drawings are what we usually do. Drawings of geometric figures are created, actually, we usually do a sketch. We freehand it most of the time. A drawing uses measuring tools such as a ruler and a protractor. Constructions, which I'm getting ready to show you how to do, are methods of creating these figures without the benefit of measuring tools. Generally, only a pencil, straight edge, and compass are used in construction. So look, when you buy your protractor, make sure it's one that has a straight edge on it, okay? Get one of the half circle ones. Don't get a whole circle one. Get a half circle one. Because the biggest thing you're going to use the protractor for is as a straight edge, all right? Sketches are what we usually do. That's when you freehand it. So look, we're going to copy a segment, and we're going to follow these steps. So I want you to just watch me, because most of you don't have your compass and ruler today, and that's okay. I didn't tell you had to yet. I want it by Monday. All right, and again, if you can't get one, I'll loan you one for the rest of the year. But see if you can get you one. All right, so we're going to draw segment JK. All right, let's see. I'm going to raise this up. Look at the steps in the book. I need some room to work here. Segment JK. So I'll use my little. There it is. Segment. Oh, come on. Let me write. Why won't it let me write? This is frustrating. There we go. I don't know why it started working. Why does it work? I know what. Okay. So that's segment JK. All right. Now, it says elsewhere on your paper, draw a line and a point on the line. So I'm going to drop down here, and I'm going to draw a line. And then it says a point on the line, and label that point Q. So there we go. Okay? So I'm done with step 1. Step 2, place the compass at point J and adjust the compass setting so that the pencil is at point K. So we take our compass and we move it down here, and we put one end of it right there on J. Okay? And I'll go over this again once you have it in your hand. Now, I stretch it out until the other end is on K. So instead of using a ruler to measure, we're using a compass to measure. Okay? Everybody thinks all a compass is for us to draw circles. I'm not sure we'll ever draw a circle with it. We use it to measure. All right? All right, so I've done that. Step 3, using that setting, place the compass point at Q and draw an arc that intersects the line. Label the point of intersection R. So without moving the compass setting, I usually blow this. Let's see if I can do it right. I move this down here and set that right on Q. Since the distance between the point of the compass and the pencil of the compass didn't change, that means it's still the same, right? The distance from Q to where the pencil is now is the same as from J to K. So, oh, come on, how do I make the mark? There we go. I'll make that mark. And I'm going to move this back out of the way. So, label that, what, R? By doing that, isn't the distance from Q to R the same as the distance from J to K? That means, and I'll make that another point, that means by the definition of congruent segments that JK, let me get this further out of the way. That means that JK is congruent to QR. And that's how we copy a segment. Or that's how we make a pair of congruent segments. Okay? You want to see me do it again? Let me show you it again. Let me get a compass here. All right, so now I'm just going to do it by knowing how to do it instead of following the steps. I start with the segment, like so. I draw another one somewhere else on my paper. Okay? Label these, whatever. Oh, I'm still making lines. Label these, whatever you want to label them. Come on. This is frustrating. Go away. J, K. I'll start here with Q. Then I get the compass. Put one in at J. Stretch it out so that the other end is at K. Okay? So, don't change that distance. I've got the length between J and K on my compass. So then I move here, put the end at Q, bring it down, make an arc, move that out of the way. That's R, JK, move that further out of the way. It's congruent to QR. You'll be able to do that, won't you? All right. Your assignment is on page 18. It's to do 5 through 9, 21 through 26, 34, 42 through 45, and then construct a copy of a segment. So you'll just get to do your own. Just draw a segment, or you use a straight edge to put a segment on your paper, and then follow those steps to construct one that's the same length as it.